So today's the last lesson of Chapter 10, Section 7. It's going to be the easiest of all of them. Chapter 10 in total. We're done after today with Chapter 10. So we are going to be writing and graphing equations of circles. You will do this again next year in Algebra 2. You will be dealing with all kind of circles, conic sections. So you will see this again next year, whether you take regular or honors. Okay, so the first slide is referring to a circle. And again, it's slow here. Wait for it to catch up. Here is when the circle is at the origin, when the center of your circle is at 0, 0. Okay, your radius length will be represented by the letter R in this slide. And your equation for the circle, and this is only when the center is at 0, 0, is x squared plus y squared, and then whatever the value of your radius is, it's squared. So for example, if I told you our radius here had a length of 3, our equation for our circle would be x squared plus y squared equals 3 squared, and then I would simplify that to x squared plus y squared equals 9. So when the center is at the origin at 0, 0, all you need to do is find the length of the radius and square it. It's pretty basic. Right here, this is the base formula for a circle when the center is at 0, 0. So the things we've been talking about lately are like y equals mx plus b. This is the base formula for a linear equation. So this is the standard form here for a circle. So what we need to fill in is the value of r. So this is only when the center is at 0, 0. We're going to see when the center is not at 0, 0, and it's going to be a different formula. Does that answer your question? Okay. So basically what you need to find out is when you want to come up with your equation of the circle is make sure that the center is at 0, 0, and also find the length of the radius. All right. It wants us to write the equation of the circle that's shown. Notice the center is located at 0, 0. I need to find the length of my radius. The easiest way to find it is think about the compass, north, east, south, and west. So if you were to count how many spaces it went up north, it went up 5 spaces. Or if it went to the side, notice this point here on the edge of the circle is at 5. Or even if you counted down, it's 5. Or to the left, the radius length, no matter which direction you chose, the radius here was a length of 5. So now I'm going to use my formula, and it's going to be x squared plus y squared equals 5 squared. X squared plus y squared equals 25. So as long as your circle center is at 0, 0, find the length of the radius and then square it. So here we were given a graph of the circle. We could see that its center was 0, 0. So we had to count the number of squares to find the length of the radius. Because remember, wherever you draw a radius, it's going to be the same measurement. If I were to draw in a diagonal radius here, like I just did with the black line, I would have to do the distance formula to figure out this. So it's a lot easier if you just count the spaces along either the x or the y axis to get the length of the radius. All right, here we have 3 examples. Notice that all of the centers on all 3 parts, A, B, and C, all of the centers are at 0, 0. So the formula again we're going to use is going to be the x squared plus y squared, and then equals the radius squared. So basically all we need to do is square all of these numbers because the x squared and the y squared stay. So for example, on part A, I'm starting out with my x squared, y squared, and then I'm going to put 4 equals 4 squared. I have to simplify that and turn that into x squared plus y squared equals 16. Okay, for part B, we're going to, again, square this radius. Okay, remember when you square a radical, what happens to it? Kimberly? Okay, it makes the radical disappear, it takes it away. Because you're squaring 5, which turns into 25, and then the square root of 25 is 5. So this will simplify to x squared plus y squared equals 5. And then the last one, this one's going to involve the most work. So remember, we need to square this. But remember, this exponent is going to distribute to the 4 and to the radical 3. So 4 squared becomes 16, and then radical 3 squared is just going to be 3. And then 16 times 3, it now equals 48. So my answer for part C is going to be x squared plus y squared, but it equals 48 because I already squared the radius up here. Now we're going to look at the standard equation when the center is not 0, 0. It's going to be some order pair on the coordinate plane. Okay, the center is going to be represented by the letters H and K. So here, we're going to put it under the radical. So x minus the h, which is going to be the x of our center, the x coordinate, and then y minus k, which will be the y of our center, equals radius. Now notice, they've got it under a radical, but as soon as we square both sides here, it causes the radical to cancel. So then the standard equation for a circle, when the center is some other order pair other than 0, 0, is this. Now, you can memorize this formula and use it for the 0, 0.
Wait, what is the H one?
The H is going to be the X of our order pair of the center, and the K is the Y. Yes?
So you're going to have like x. Wait, what is the first equation? Why is it different from the second equation?
They're showing you how it was developed. So basically it's like the distance formula. So we're basically doing the distance to find this, and we're turning it into a circle equation. So you don't need to memorize this one.
So that one is
That's just showing you how it was created.
Hold on, they only use the letter H and K, so it won't confuse us with the other X's.
Correct.
Okay.
Instead of calling it X1, Y1, they're now calling the center H and K. And you're going to be doing this a lot in Algebra 2, seeing this HK.
So it would be X minus X squared plus Y minus Y squared.
Basically, yes. But that X and Y are the coordinates of the center.
So what are the first X and Y?
It's just the part of the formula. They stay there. It's sort of like the Y and the X and the Y equals MX plus B.
So you have to like solve for like substitution?
You're going to be doing that in Algebra 2. So same thing that you did in Algebra 1 with linear equations, finding the order pair where the lines crossed. You're going to do the same thing in Algebra 2, but with circles. And you'll be doing 2 circles intersecting, a circle and a line. But again, you're going to use the same methods of substitution and elimination. Yes. All right, so now we're actually going to add some numbers to this so we can see it in action. So here we go. We want to write the standard equation of the circle with a different center this time, not 0, 0. And we actually have 3 different problems on this slide. And again, I'm waiting for it to catch up. Here we go. All right, so again, remember the standard form of the equation is this. X minus h squared plus y minus k squared equals radius squared. There we go. Okay, so this is the formula I'm going to use. Remember the center over here, this 1, 2, is going to be the HK. And then the radius, of course, is your letter R. So I'm going to take those 3 numbers from part A, example A, and I'm going to replace them in the formula. So for part A, I'm going to replace the 1 for the H, the 2 for the K, and the 4 for the R. The only thing I'm going to simplify is the 4 squared. So my standard equation for this circle is going to be x minus 1 squared plus y minus 2 squared equals 16. Notice when you put in the center points, that subtraction sign is part of the formula. So basically you're putting them in and making them look like they're opposite signs. Notice the radiuses for this are the same ones that we did when the center was 0, 0. So for part B, again, we're going to put it into this yellow standard form. And we're going to do x minus -3, which turns it into +3. So when you put in the center, basically put it in as an opposite sign. Plus y minus 5 squared. And then when I square root the 5, or square the radical 5, it just turns into 5. And it now appeared. Everybody understand how I put in that center and I flip the sign? Because in the original formula, remember it's negative, negative. And negative, negative turns positive. Let's look at C. Now remember in the previous problem, or the previous slide, when we squared this radius, the 4 radical 3, it became the exponent of 2 went to the 4 and to the radical 3. So this turned into 16 times 3. So for my formula, I'm using 48. So again, I'm going to use x minus 0 squared plus y negative, negative plus 2 squared equals 48. Yes?
Can you simplify it to x squared?
You could. Yes, that's what you're going to be doing a lot in Algebra 2. So if you simplify to x squared and then y plus 2 equals 48, that's fine. I would accept either answer on your test. Okay, so now we have the graph on the coordinate plane. We need to come up with the equation. Notice both of these circles do not have their center at 0, 0. So we need to figure out the order pair for the H and the K, or for the center, which is labeled for us. So really all we need to calculate is the length of the radius. So in my figure for part A, this is H, this is K. How can I figure out the length of my radius? Gabby. Count the squares. How many squares do I count here? 1. So this has a radius length of 1. So I'm going to use my standard form here, and I'm going to do x minus h squared plus y minus k squared equals r squared. So again, I'm going to replace the h with 4, replace the k with 1, and then put in 1 squared, which is 1. And that's your answer. Now we'll refer to figure in part B. Again, they already labeled the center for us, but we do need to count the squares to find out the length of the radius. So again, the -5 is h, the +3 is k. What is the length of my radius here? 3. It's got 3 little squares. And the easiest way is to either count it up and down or side to side. And it doesn't matter if you go to the left, the right, up, or down. So this has a radius length of 3, and then my center is -5, 3, which is my hk. So again, I'm going to do x, and it's minus minus, so it turns into a +5, and then y minus 3, these are all squared, and it equals the radius squared, which is 9. So here, to graph the equation, we're going to pull out the center. Do that first. Okay, so remember, your center point is this h and k. And know that when it went in opposite, so when it comes out, it's opposite. So see how this looks like a -3? But what's coming out is +3, and over here is going to come out a -1. Then the radius, remember, was squared, so my radius length for this first one is going to be 2. So I'm going to first plot the center. So I'm going to plot or graph the ordered pair 3, -1. So I'm going to come over here and put my dot right here, and it'll appear in a minute. And then from there, I can count my radius. I can go like the compass, go north 2, east 2, south 2, west 2. So count 2 squares up and put a dot there, 2 squares to the right, 2 squares down, 2 squares left, connect your dots, and form your circle. And that would be the graph for part A. For part B, we need to pull the center out. So for part B, we're going to pull out the 2, and it's backwards, so it's -2. Notice nothing being added or subtracted here to this y, so I know it's 0. And then again, my radius has a length of 2, because the square root of 4 is 2. So again, I'm going to plot my center at the ordered pair -2, 0. And then from there, go 2 up, 2 to the right, 2 down, and 2 to the left. And connect your dots, make your circle. And that's how you graph it from a standard form of the circle equation.